So I thought I'd start by saying a little bit about myself. So my name is Steve Hopkinson. I'm a full stack developer, a JavaScript developer. And I'm currently working at Publicis.sapient, Sapient for short, as a technology manager. Currently, I'm a software architect and back-end engineer building APIs for a major banking group. But prior to that, I was a full stack dev at a digital product agency. And prior to that, I was a solution architect on a central government project I was working on through IBM. And way back, I started my career as a database administrator, which might explain some of the odder things that I obsess over the following 30 minutes. But before we start, a story. So about a year ago, there was a research paper published by two academics called Gavlett and Johnson called The Genre Effect, and it was published in a journal called The Scientific Study of Literature. And what the study did, the researchers split their subjects into two groups and had each group read a version of a passage. The first passage just read like plain literary fiction, and the second version had some non-critical kind of scene-setting words replaced with terms that sounded a little bit more science fiction. So instead of door, it said airlock. Instead of waiter, it said cyborg, that type of thing. The usual substitutions. And when they then tested the readers afterwards to see how well they'd engaged with the material they were reading, the people who read the science fiction version scored markedly lower on pretty much every metric. They scored lower for empathy with the characters. They scored lower in terms of how well they understood what was happening in the story. They scored lower for something that's called theory of mind, which is how well they were able to imagine what characters were thinking. And this is despite the fact it was exactly the same passage with only insignificant words changed. And the conclusion was that the science fiction setting triggered poorer overall reading. Now you may be wondering, why am I telling you this? And there's a good reason. If we replace literary fiction with JavaScript and science fiction with databases, we have the exact thing I discover every time I talk about databases. An audience that would normally be incredibly excited and engaged talking about an interesting JavaScript topic will completely switch off when you talk about databases. So with that in mind, I'm going to talk about databases. Please stay engaged. So this is the database deficit, which is something I've observed in a number of teams that I've worked in, and how this blind spot that a lot of full stack developers have is having a negative effect on agile teams. So to give a little bit of context before I dive in, I've worked across a number of teams that were primarily staffed with full stack developers, generalists rather than specialists. And not all of them, but for many of them, it seemed that the database was treated as an afterthought. And on each of those projects, that caused pretty significant issues in their ability to deliver effectively as an agile team. So I'll go into that in a little bit more detail as we go through. So how did we get here to this point where a lot of teams just seem to have quite inadequate database fundamentals? So first of all, let's look at the rise of the full stack developer, because we all take full stack devs for granted. Can I see a quick show of hands? How many of you identify as full stack devs? Okay, so maybe about half of you, and how many of those just say that on your CV so you can get better jobs? Anyway, as of about 5 years ago, full stack developers weren't something people really talked about. You had much more specialism. And then around the beginning of 2014, there was this explosion in full stack developers, which incidentally kind of coincides with a kind of production-ready release of Node.js, and I don't think that's completely a coincidence. But nowadays, full-stack developers dominate a lot of software engineering teams, and you can understand why. With best practice, we're shifting towards smaller software delivery teams, because I think we all understand that as teams grow, the burden of having to communicate what you're building around a larger group of people grows and grows, and actually, you know, the productiveness of the team does not scale linearly with the number of developers that you have. But the problem with having smaller teams is that there's less room for specialists. You know, if you have a couple of sprints where you're focusing on back-end work and then suddenly you need to focus on delivering some back-end infrastructure, that's difficult to do if you have a team that's composed of people specializing in front-end or back-end. So inevitably, as a part of this change in how we approach delivering software as teams, full-stack developers have come to dominate. And as I say, this didn't really start until 2012 and not really seriously until 2014. As I say, that coincides with the first major release of Node. But over the same period, searches for database dropped by 50 to 80%. Now, surely, if the size of development teams and the prominence of software development within the economy and the world is growing, you'd expect these things to kind of go up together, but interest in databases has fallen off pretty catastrophically. And when we talk about full stack developers, what do we actually mean? What is the full stack? Because a lot of us who write Node and React, say, might consider ourselves full stack developers, but surely there's a lot more to it than that. As a developer, you're expected to know a wide range of generic skills, Git, Jira, Jasmine, Bash, Cucumber, ESLint, and others, which are kind of stack agnostic. You know, you're going to know those regardless of what area of the stack you're working on. And then as a front ender, there's a huge array of things that you need to know about. ES6 we're probably all pretty comfortable with now, HTML5. A lot of people still don't use CSS preprocessors like Sats. If you want strong typing, you've got to learn something like TypeScript. Everyone now is expected to learn React, Redux, or something like MobX. Build tools like Webpack and Babel. You know, this is a lot of complex tooling that you need to get your head around. And as a full stack developer, this is just one of the layers that you're working on. As a back-end developer, it's not much better. You've got to learn Node, you've got Express sitting on that. You have a whole range of CMSs that you might be using depending on your client. ORMs like Sequelize and Loopback, GraphQL, microservices, different architectures. Things very quickly start to become problematic if you're expected to be able to deliver on all of these, and it doesn't stop there. You know, if you're expected to also be delivering the database, you're not just talking about SQL, whether that's Postgres, you're looking at NoSQL databases, you're looking at graph databases, and quickly you get into DevOps, and frankly, things are getting silly. So realistically, is one developer going to be able to do all of this equally competently? I'd argue probably not. And I'd argue that if you have a team primarily made up of full stack devs, the one side where they're likely to fall down is when you get to the database, possibly the nitty-gritty of the back end, and many more. So this is the terrifying fall of the database. This is the decline in searches for database itself and also for SQL, which is, it's not entirely obvious from that chart, but 20% of what it was 14 years ago. And yeah, I'm willing to bet pretty much all of us working on projects where that's still playing a pretty fundamental part of our tech stack. So where's the interest gone? And what's there in its place? So we end up with these developers who, like all of us, are not equally proficient across all of the layers in the stack. And a lot of full stack devs I know started in the front end and then became full stack developers by picking up some Node or maybe some Python. But the database still remains the kind of furthest point from that starting position. The weakest layer is, for many, the database. And why is this? I've got a few theories. They're not all backed up in data, so give me a little bit of slack. But part of it is that software development has kind of become a lifestyle choice. You know, as far back as 2012, the TechCrunch writer John Evans was saying that suddenly programming is sexy. People are choosing to go into programming because it's now an attractive thing to be. And frankly, being a database administrator 20 years ago wasn't something you wanted to talk about at dinner parties. And frankly, if you did, good luck to you. You're probably not getting invited back. it's also the matter that, you can work on the front end and on the server side using JavaScript, but SQL it's a different beast. And a lot of devs I work with, they won't openly say it, but they're not really that comfortable working in SQL. They don't have an intuitive feel for how joins work. They're having to Google the syntax every time that they use it. And not only that, but there are conceptual gaps. As we know, JavaScript is imperative programming, well, it's kind of a number of paradigms, but SQL is a very different approach to how we structure the code that we're writing. And also, database admin is kind of an ops role, right? We used to leave that to the operations team and not worry about it as developers. And somehow in this transition to full stack, a lot of that ops capability got kind of left behind and fell between the cracks a bit. And not just that, most developers don't get exposed to it. Boot camps where a lot of developers are getting into the industry now will spend a pretty negligible amount of time on the database and not really go into a lot of depth about it. And equally, if you're a front-end developer who's been in the industry for a few years, it's unlikely that you'll have the exposure to working on databases to be able to bring those skills to the team. And when a full team of developers shares that weakness, the impact on the software that you're building is amplified. If everybody has the same blind spot, then that becomes a real problem for your team. And the point of agile, right, and the point of Scrum and a lot of these ways of working together is that everybody needs to be working together in harmony. Because particularly when you get into approaches like continuous integration and continuous development, the team needs to be firing on all cylinders across the stack. You can't do continuous development if the changes to your database are being handled offline through a separate process outside of your usual deployment pipeline. So how does this look in practice? How do you know that your team has an issue with this type of thing? Well, for me, the biggest red flag is how you handle database migrations. I've come onto a number of projects that were kind of already up and running, and the first thing I always ask is, how do you handle your migrations? Well, the first thing I'll do is poke around the code base and see if there's a thorough and comprehensive folder of migrations. Because without that, you can't have truly automated deployment pipelines. If as part of the changes that you're making to applications, you are committing changes to the database, then that means that you need to be able to test by spinning up a new database that's not the same structure as the one you might have in master or whatever your working branch is, and validate that it's working. And if you're just working from a single database that you're connecting to, then that can become very problematic. But you can't spin up these transitive databases unless you have a pretty thorough set of migrations to build one from scratch. So incomplete and absent schema migration files. The most frustrating thing is when you come to a project and there are some migration files, enough to replicate a couple of the migrations that have happened over the past few years, because it doesn't help you at all. They have to be comprehensive or not at all, because otherwise you can't go from point 0 to the current working state if you don't have documentation of every step in between. And again, one of the symptoms of this is if you find that database migrations have to be handled outside of the usual development pipeline. If normally you just deploy changes by committing the code to GitHub, that might trigger a Jenkins build, say, and you get the all clear. But when you have a database migration, somebody has to go and manually run a load of SQL queries against a command line interface, which is something I've encountered on a couple of projects. It's not a strong sign for your project, and that would definitely show up as a red flag. And this is a favorite. Have you ever joined a project and been told that to set up your local dev environment, you have to be emailed like a gigantic dump of the latest production version of the database, and then like spin it up from scratch? And then maybe they say, but we've changed a couple of things since then, so maybe run these queries as well. Yeah, it's not pretty. And the losses that you get through having to do this over time really accumulate. Another issue if you don't have the specialism in databases is picking the wrong kind of database for the use case. You know, if you're building an application where the integrity of your data is sacrosanct, and where it's important that when you have multi-table transactions taking place, that everything is committing correctly before the transaction completes, then don't use Mongo. Don't use a NoSQL database, because that's really not the correct use case. But on the other hand, if you have a SQL schema on a code base that needs to scale, and that you're just constantly dumping JSON strings into, then maybe that's not the right database for you either. I'm sure we've all worked with schemas that are difficult to reason with, where you maybe look at a schema diagram of the database, if you're lucky enough to have one, and nothing makes any sense. Maybe the same entity will be called different things in different places. You'll have to perform complex joins to perform basic business logic that should be fairly intuitive. It's not fun to work with. And finally, this is one of the worst ones I've come across, a team that found it so difficult to do database migrations that instead of actually migrating the database, they just dumped all of the new fields into a JSON string, pulled the entire database, and then filtered against it in the back end. I mean, stuff can get pretty rough. And I hope for all of your sakes, it's not that bad on any of your projects. So what are the core skills that you can arm yourself with to prevent your team getting into this situation? Well, the first one is understanding what the pros and cons of each database are. You know, I know relational databases are kind of not in vogue right now, but a lot of the time they are the right tool for the job. And you know, we shouldn't be making fashion-based decisions about our tech stacks. You know, document-oriented databases are wonderful for what they do. And certainly if you're building a huge app, you know, particularly kind of in the social media area, something that needs to scale very quickly, then that might be the right tool for you. But equally, the skill of being able to create a well-reasoned and scalable data model is one that's valuable not just when working directly with databases, but when you're working with data anywhere in your app. A well-designed data model, one that has the minimal of duplication, one that's properly normalized, one in which your entities and tables relate in a fairly intuitive way to the business and real-world concepts that you're dealing with, is something that will make your application much easier to develop in future and will be a godsend to any new developers joining the project and trying to make head or tails of it. But equally, that's a skill that transfers across to things like designing the Redux store that you're using in your front end, or designing the models that you're using in Sequelize on your back end. But for me, the absolute killer is making sure that all of your migrations are written in a way that they are incremental, reversible, and programmatic. And what I mean by that is, for each small change you make to your schema, you should have a single migration. And not just that, the migration should be able to get you from version 2 to version 3, but also back again, if you realize that you need to revert. Because there's nothing worse than realizing you have to roll back a change and finding that you don't have database script required to do that, and then having to drop tools and go and work on that separately. And they need to be programmatic, because if they can't be run automatically, programmatically, then they can't be incorporated into a continuous integration, continuous deployment pipeline. Committing them to your code base is the issue of version controlling databases, database schemas, is not one that's been solved in a particularly attractive way, but of all the unattractive solutions that we have, committing migration files to your repository is probably the best one. And again, this allows for automatic migration as part of your deployment pipeline, and also the ability to spin up your databases for scratch as part of your testing environments, your validation steps in your CD pipelines, so on and so forth. So given that we now know all of those negatives. How do we avoid this happening in the first place or mitigate against it if we find that we already have this issue? So it's amazing how infrequently full stack developers are asked anything about databases in interviews. I think I've had one database-based interview question in the entire time I've been working as a software engineer. And actually, that was for a company that built pretty exceptionally well-structured applications. And I don't think that's an accident. There are simple whiteboard exercises you can use when you're hiring to drill down into how much your candidates know about dealing with that side of things. You know, give them a schema diagram and ask what changes they'd make in order to incorporate a feature request that you throw at them. And ask them to talk through the decisions that they're making. You know, these are simple exercises. They don't need to take more than 5 or 10 minutes. But they can help you guard against building a team where, frankly, there's nobody who has strength in these areas. Pointing existing team members towards online resources. There is a depressing lack of strong online resources about working with databases online. There's some stuff on Udemy, but on the whole, when you consider how many decent free resources there are for working with React, Redux, Node, the stuff that's out there for SQL is pitiful in particular. And the websites are all so terribly designed. So front-enders who take that kind of stuff seriously, maybe just close your eyes and dive in. It's not going to be pretty. And I've got a few links that you can follow at the end of the presentation. But also, if you're sitting here thinking, actually, shit, my project doesn't have incremental migrations, this isn't something that we're capable of doing, it's not too late to add them. You know, it's fairly easy using the right tooling to create a script that will rebuild a database in whatever state you currently have in production. You know, translating a database dump into a SQL query that will build it up from scratch. And from there, you can just start incrementally adding further migration scripts before things get too out of hand. So it's never too late to start using these techniques. So thanks very much for listening. I hope you found it interesting. And yeah, hope you enjoy the rest of your evening.